Welcome to a brief review about bond valuation. You thoroughly explored this topic in Business 591, Financial Policies and Principles course. The concepts are reviewed in this resource module because bond valuation methodology is a core component of this week's content. And you should be expected to be tested on this subject in this course and on your CFP exam. I trust that the information in this review will sound quite familiar to you. So, let's get started. You learned in Business 591 that bonds have 5 common variables. If you know any of the 4 of the 5, you can solve for the 5th. Those 5 variables, again, are price, which equals the PV or present value, the principal or the face value or the par value of the bond, and that equals the FV or future value, the maturity date, which is the N or the number of periods, the coupon payments, which equals the PMT, and the interest rate, which might be referred to as the current market yield to maturity on similar debt, the interest rate, the discount rate. Let's begin by looking at the zero coupon bond. The price of a zero coupon is simply the present value of the one-time cash flow. So question, how much would you have to pay today to purchase a $10,000 zero coupon bond that matures in 10 years if it is offered at a 5% yield to maturity? On this slide, you see the data inputs for this valuation using the financial calculator. Because the zero coupon bond doesn't offer any periodic payments, the PMT is equal to 0. The only inputs are the FV of $10,000, the number of periods N, which in this case is 10, and the interest or the discount rate I of 5%. After inputting the data, simply click on the PV key to discover the cost of the zero coupon bond, which in this case is $6,139.13. The more common debt security is the coupon paying bond. When pricing a coupon bond, you need to think about the timing of the periodic cash flows and the receipt of face value at maturity. Let's work through a coupon bond valuation example. Question, how much do you have to pay to purchase a $100,000 5% bond that matures in 5 years if the current market rate of interest on a similar security is 4%? Note, in this problem, you're given the face value, the payment yield, i.e. 5% of $100,000, the number of periods, and the discount rate. Therefore, you can solve for the price. Using present value tables is one way to work a bond valuation problem. Based on the data from this question, you know that the future return of principal payment is $100,000. That is a one-time payment that will be received at the end of the 5th year. You also know that the bond pays a 5% coupon on an annual basis. Therefore, you can expect to receive $5,000 at the end of years 1 through 5, i.e. $100,000 face times the 5% coupon rate is equal to $5,000. So, the answer to this problem involves adding the present value of the return of principal payment to the present value of the annuity stream. Referring to the table on this slide, you see that the PV factor for a one-time cash flow received in 5 years is 0.822, and the present value annuity factor for the stream of cash flow is 4.452. Given the face value, the coupon payment, the number of years to maturity, and the discount rate, the present value is $100,000 times 0.822 plus 5,000 times 4.452, which equals 104,460. The financial calculator is an efficient way to solve for the bond's price. You're given 4 of the 5 variables, so the process is as follows. Input 100,000 is the FV, 5,000 is the PMT, 5 is the N, and 4 is the I, and then hit PV. One important point to remember when using a financial calculator is that you must identify cash outflows as a negative number and cash inflows as a positive number in order for the function to work. In this example, as the purchaser of the bond, you expect to receive plus $5,000 each year, that's your PMT, your annual cash flow, and plus 100,000 return of principal at the end of the 5th year. That means the present value PV will be equal to a negative 104,452. That's how much you would have to pay, take out of your pocket to get those future income streams. If you calculated the example from the position of the company issuing the bond, you would input a negative 5,000 for the annual payment, because you have to pay that to the bondholder every year, and a negative 100,000 for the return of principal, because you have to pay the 100,000 to the bondholder. That means that the present value will equal a plus 104,452. That's because you received that money today. Financial spreadsheets are an excellent tool in pricing a financial instrument or corporation. Take a careful look at the table on the slide. You will notice that a present value is calculated for each of the years. That string of present values are added together to equal the price of the bond. This process essentially looks at each cash flow as its own zero coupon bond. The beauty of the financial spreadsheet is that you can quickly see every cash flow that you put into it, the interest rate used, and the time periods. So, where does that PV factor come from? That's just the formula 1 divided by 1 plus the interest rate expressed as a decimal. Do you see how easy that is to program? For example, if the years appear in column A, the interest rates in column B, and all the data for period 1 is in line 4, then the cell formula in Excel simply equals 1 divided by, in parentheses, 1 plus B4 raised to the power of A4. Notice that the year 5 cash flow is $105,000. That is because you received both the return of principal and the annual payment at that end of the 5th year. This is a little different input than with the financial calculator. In that approach, the PMT is set up to signify the periodic payments, including year 5, and the FB is set up to signify the one-time payment. Note that Excel also has a net present value function, NPV, that you might prefer to use rather than setting up this formula. What happens if the payment is semi-annual? Let's answer this question by working through the same problem and only changing the coupon payment from annual to semi-annual. Question: how much would you have to pay to purchase for the similar $100,000 5% bond that matures in 5 years if the coupon payments are made semi-annually and the current market rate of interest on a similar security is 4%? Many coupon bonds pay on a semi-annual basis, for example, the U.S. Treasury bonds. In calculating a semi-annual bond, all you have to do is adjust the period coupon payment, i.e. the payment divided by 2, the number of periods doubled, n times 2, and the interest rate cut in half, I divided by 2. Once that data is adjusted, calculate the value of the bond in the same manner as completed in the prior example. Let's work this problem with the financial calculator. The inputs for the calculator are depicted on this table. Notice the face value remains at $100,000. The coupon payments are cut in half, $2,500, because you receive them twice a year. The number of periods is doubled, so 5 times 2 is 10. And the interest rate is cut in half, shown here as 2%. Solving 104 with 491. You discover that the present value of the bond increased slightly. The reason for the slightly higher increase is that some of the cash flows are realized sooner than those that were realized with the annual coupon bond. That was only received at the end of the year. As you know from your study of time value of money, when holding the discount rate constant, identical cash flows received in earlier periods are worth more than those received in later periods. The spreadsheet methodology is the same as before. The only difference in appearance is that there are 10 periods rather than 5. The discount rate is 2% rather than 4. The periodic cash flows in those 10 periods is $2,500 rather than $5,000. And as explained, the 10-year cash flow includes both that return of principal payment, $100,000, plus that last coupon of $2,500. Companies often issue bonds with call options to protect themselves against falling interest rates. If rates fall significantly, the company can call the old issue and replace it with a new bond issue at a much lower interest rate. That can save the company a lot of money. For this example, the company has to pay a higher going interest rate of interest and a call premium. Investors should know the yield to call before investing. Let's look at an example to make sure this yield to call concept is clear. Question: the yield to maturity for a $10,000 5% bond that matured in 5 years and cost $9,500 was 6.2%. What is the yield to call if the company can call the bond in 2 years at a price of $10,500, i.e. the premium is 5%. So that total return is 105%, or $10,500 rather than just the $10,000. Notice in the question that the return of principal is at $10,500. The higher amount reflects the call premium. The only other change from the original variable inputs is the number of periods, n. Since the issue is being recalled, the n is now 2 years instead of 5. The table on this slide shows the method for calculating the yield to call with the financial calculator. One of the challenges in answering bond valuation questions on exams is the vocabulary. Test writers can use several different terms to describe the same variable. For example, N can be described as the number of periods, years, or the maturity date. I can be identified as interest rate, discount rate, yield to maturity, required rate of return, yield on similar debt issues. PV might be called price, value, present value. The payment could be given to you as a dollar amount, or indirectly by giving you a coupon rate and the face value. In this case, as you can see, that payment was $5,000 because 5% of $100,000 equals your $5,000 coupon, your PMT. FV might be described as future value, par value, face value. You know that the test writer has to provide 4 of the 5 variables. So take your time identifying what terms are being used, and that should help you work through the problem. That concludes this review resource. In this lesson, you reviewed bond valuation, zero coupon bonds, annual coupon bonds, semi-annual coupon bonds, and callable bonds.